For solving problems of integration, we are using some important methods of integration. A. Integration by substitution. Integration by substitution. Example, integration of log x by x dx. Here we can see that derivative of log x is equal to 1 by x. We can solve this by substitution. Substitute log x is equal to t differentiated 1 by x dx is equal to dt. Therefore, integration of log x by x dx is equal to, instead of log x we put t. Instead of 1 by x dx we put dt. This is equal to t square by 2. Integration of x raised to n dx is equal to x raised to n plus 1 divided by n plus 1. It's equal to t square by 2 plus c equal to we know t is equal to, we substitute t is equal to log x. So substitute instead of t log x. Log x the whole square by 2 plus c. The above given 10 results when x is replaced by ax plus b can also be solved by substitution. Result 1. Integration of ax plus b the whole raised to n dx. Here we can put ax plus b equal to t. Differentiate. A dx is equal to dt. Therefore, implies that dx is equal to dt by a. Therefore, integration of ax plus b the whole raised to n dx is equal to integration of, instead of ax plus b we put t raised to n. Instead of dx we can write dt by a. Since a is a constant, that is 1 by a, we can take outside of integration. That is 1 by a into integration of t raised to n dx. That's equal to 1 by a into t raised to n plus 1 divided by n plus 1 plus c. You know, integration of x raised to n dx is equal to x raised to n plus 1 divided by n plus 1. Replace t by ax plus b. It's equal to 1 by a into ax plus b the whole raised to n plus 1 divided by n plus 1 plus c. Result 2. Integration of e raised to ax plus b dx. Here we can substitute ax plus b is equal to t. Differentiate. A dx is equal to dt. Implies that dx is equal to 1 by a dt. Therefore, integration of e raised to ax plus b dx is equal to integration of e raised to a. Instead of ax plus b we put t, and instead of dx instead of dx 1 by a dt into 1 by a dt is equal to 1 by a we can take outside of integration of e raised to t dt. It's equal to e raised to t plus 1 by a into e raised to t plus c. Since integration of e raised to x dx is equal to e raised to x plus c. That's equal to 1 by a into e raised to, instead of t we replace ax plus b. ax plus b plus c. Result 3. Integration of 1 by ax plus b into dx. We keep in mind that integration of 1 by x dx is equal to log x plus c. Here we compare these two. When we comparing these two, here ax plus b, here x. Instead of x, here ax plus b. So we substitute ax plus b is equal to t. Differentiate. A dx is equal to dt implies that dx is equal to dt by a. Therefore, integration of 1 by ax plus b dx is equal to integration of 1 by, instead of ax plus b, we put t. 1 by t, instead of dx, we replace dt by a into dt by a. We can take 1 by a, which is constant, we can take outside of integration. 1 by a into integration of 1 by t dt. This is equal to 1 by a into log t. Integration of 1 by x dx is equal to log x plus c is equal to 1 by a into log, replace t by ax plus b, log ax plus b. In the same way, we can also integrate the remaining 7 results by integration by substitution method. We do some more problems by the method of substitution. Question number 40. Integration of log x the whole square by x dx. While going through this question, we can see that d by dx of log x is equal to 1 by x. So, we can substitute log x is equal to t. Implies differentiate 1 by x dx is equal to dt. Therefore, integration of log x the whole square divided by x dx is equal to integration of, replace log x by t, integration of t square, replace dx by x, 1 by x into dx into dt. This is equal to t cube by 3 plus c. So, integration of x raised to n dx is equal to x raised to n plus 1 divided by n plus 1. Again, we replace t by log x. It's equal to log x the whole cube by 3 plus c. Question number 50. Integration of e raised to x minus e raised to minus 2x the whole divided by e raised to 2x plus e raised to minus 2x into dx. While going through this question, we can see that the differentiation of e raised to 2x plus e raised to minus 2x is equal to e raised to 2x minus e raised to minus 2x. So we can substitute e raised to 2x plus e raised to minus 2x is equal to t. Differentiate 1 by 2 into e raised to 2x minus 1 by 2 into e raised to minus 2x into dx is equal to dt. Here 1 by 2 we can take outside. This 1 by 2 into e raised to 2x minus e raised to minus 2x e raised to minus 2x into dx is equal to dt. Here we got a mistake in the case of differentiation. Differentiate 2 into e raised to 2x minus 2 into e raised to minus 2x dx is equal to dt. 2 we can take outside. E raised to 2x minus e raised to minus 2x dx is equal to dt. Implies that e raised to 2x minus e raised to minus 2x into dx is equal to dt by 2. Therefore, integration of e raised to 2x minus e raised to minus 2x divided by e raised to 2x plus e raised to minus 2x dx is equal to integration of, we know e raised to 2x plus e raised to minus 2x we substitute as t. Therefore, this is equal to 1 by t. Again, e raised to minus 2x minus e raised to minus 2x into dx is equal to dt by equal to, we can take 1 by 2 which is constant outside of integration, 1 by 2 into integration of 1 by t dt is equal to 1 by 2 into log t plus c. That's equal to 1 by 2 into log, instead of t we replace e raised to 2x plus e raised to minus 2x. E raised to 2x plus e raised to minus 2x plus c. Part 1 we have learned some results of integration and some properties and have been done some problems based upon that results. Here we are giving some more results of integration where x is replaced by ax plus b. First one is integration of ax plus b the whole raised to. For remembering, we have learned integration of x raised to n dx is equal to x raised to n plus 1 divided by n plus 1 plus c. Therefore, this equal to 1 by a into ax b the whole raised to n plus 1 divided by n plus 1. Instead of x, we are writing ax plus b because ax plus b having, So we are taking 1 by a into ax plus b the whole raised to n plus 1 divided by n plus 1. This can be also solved by the method of substitution. Second, integration of e raised to ax plus b into dx. Compare with the integration of e raised to x dx is equal to e raised to x plus c. Therefore, this equal to e raised to ax plus b plus c. 1 by a into e raised to ax plus b plus c is the result. Integration of 1 by ax plus b into dx. This we have to compare with integration of 1 by x dx is equal to log x plus c. Therefore, this equal to 1 by a into log of ax plus b plus c. Fourth one is integration of a raised to bx plus c dx. This we have to compare with integration of a raised to x dx is equal to a raised to x divided by log a plus c. Therefore, this equal to 1 by b into a raised to bx plus c divided by log a plus c. Fifth one is integration of sine of ax plus b into dx. Compare with integration of sin x dx is equal to minus cos x plus c. Therefore, this is equal to minus 1 by a into minus cos ax plus b. It's equal to minus 1 by a into cos ax plus b plus c. Sixth one is cos of ax plus b dx. This we have to compare with integration of cos x dx is equal to sin x plus c. Therefore, this is equal to 1 by a into sin of ax plus b plus c. Seventh one is integration of sec squared ax plus b dx. This we have to compare with integration of sec square x dx is equal to tan x plus c. Therefore, this equal to 1 by a into tan of ax plus b. Instead of x, we have to put ax plus b plus c. Eighth one is integration of cosec squared ax plus b dx. This we have to compare with the integration of cosec square x dx is equal to minus cot x plus c. Therefore, this equal to 1 by a into minus 1 by a into cot of ax plus b plus c. Ninth one is integration of sec of ax plus b into tan of ax plus b dx. This we have to compare with integration of sec x tan x dx is equal to sec x plus c. Therefore, this equal to 1 by a into sec of ax plus b plus c. Tenth one is integration of cosec of ax plus b into cot ax plus b dx. This we have to compare with integration of cosec x cot x is equal to minus cot x is equal to minus cosec x plus c. Therefore, this equal to minus of 1 by a into cosec ax plus b plus c. The following sum forms can be integrated by substitution. The integral of the form integration of f of x raised to n into x raised to n minus 1 can be integrated by substitution. X raised to n is equal to t. In second, integral of the form f dash x divided by f of x can be integrated by substitution. F of x is equal to t. Otherwise, numerator is the absolute derivative of the denominator, then the integral is log of the denominator. Third type, integration of capital F of x into f dash x dx can be integrated by substitution. F of x is equal to t. These are all you keep in your mind while integrating by substitution. The other method of integration is B, integration by parts. If the integrand is the product of two or more functions which could not be integrated by the method of integration, that is of the form integration of u into v dx. U and v are the functions of x. Integration of u v dx is equal to u into integration of v dx minus integration of d by dx of y into integration of v dx the whole dx. d by dx of u into integration of v dx the whole. Integration of u v dx, that is first function into second function. Here u is the first function, v is the second function. Therefore, integration of u v dx equal to first function in u into integration of the second function v minus integration of derivative of first function u into integration of the second function v the whole into dx. Example, integration of x into log x dx. This is the product of two functions. First function is x and x algebraic function, and second function is log x logarithmic function. While going through this question, one is not the derivative of the other. That is x, derivative of x is equal to 1, which is not here, and the derivative of log x is equal to 1 by x, which is not here. So it could not be solved by substitution. We can solve this by integration by parts. For doing integration by parts, first we write the two functions in a special order. The order is inverse trigonometry function. First one to come inverse trigonometry function, second logarithmic function, algebraic function, trigonometry function, and exponential function. Briefly, for remembering, elate, I for inverse trigonometry function, L for logarithm, A for algebraic function, T for trigonometry function, E for exponential function. In this question, integration of x log x, the order given as first x algebraic function and second log x logarithmic. As per Ilay, we write this as first logarithmic function log x and second here x algebraic function log x into x dx. This is u, this is v. So this is equal to first function u means log x into integration of the second x minus d by integration of d by dx of first function log x into integration of the second function x the whole into dx. That's equal to log x into, we know integration of x is equal to x square by 2 minus integration of, we know d by dx of log x is equal to 1 by x and integration of x is equal to x square by 2 into dx. That's equal to log x into x square by 2 minus integration of 1 by 2 x dx. That's equal to log x into x square by 2 minus 1 by 2 into integration of x dx is equal to log x into x square by 2 minus 1 by 2 into x square by 2 plus c. We can take x square by 2 as common. That's equal to x square by 2 into log x minus 1 by 2 plus c. Another form of integration by long division method. In p by q form, p and q are algebraic expressions of same variable. Example, x divided by x plus 1. If the degree of the variable of the numerator of the integrand is equal or greater than denominator, divide numerator by denominator until the degree of the remainder is less than denominator by long division method. Example, x divided by x plus 1. Here numerator is x, here the degree of the variable is 1 and denominator is x plus 1 and the degree of the denominator is also 1, and these are algebraic expressions. So suppose Integrate x divided by x plus 1 dx. Divide x by x plus 1 by long division method. X divided by x plus 1. Here x into 1 is equal to x. Therefore 1 into x is equal to x. 1 into 1 is equal to 1. This 0, 0 minus 1 minus 1. Therefore, this is integration of x divided by x plus 1. We can put 1 plus 1 minus 1 divided by x plus 1 into dx is equal to integration of 1 dx minus integration of 1 by x plus 1 dx. That's equal to integration of dx is equal to x minus integration of 1 by x plus 1. Here denominator is x plus 1. The derivation of the denominator is 1. Therefore, numerator is the exact derivative of the denominator. So, we can write integration of 1 by x plus 1 as log of x plus 1 plus c. We do some more problems based upon the above studies. Question number 40. Integration of log x the whole square divided by x dx. While going through this question, we can see that derivative of log x is equal to 1 by x. So, we can substitute log x is equal to t. Differentiate 1 by x dx is equal to dt. Therefore, this equal to, instead of log x, we can write t. T square into, instead of 1 by x dx, we replace dt. This is equal to integration of t square t cube by 3 plus c. We replace t by log x. That is equal to log x the whole cube by 3 plus c. Question number 50. Integration of sin squared x divided by 1 plus cos x dx. This is equal to, we know that sin square x is equal to 1 minus cos x. The denominator is 1 plus cos x. So here instead of sin squared x we write 1 minus cos squared x. 1 minus cos squared x divided by 1 plus cos x into dx. This is equal to 1 minus cos squared x. We can write as 1 plus cos x into 1 minus cos x. That is 1 plus cos x into 1 minus cos x divided by 1 plus cos x into dx. This is a square minus b square is equal to a plus b into a minus b. This is equal to 1 plus cos x, 1 plus cos x we cancel. Therefore, integration of 1 minus cos x dx. This is equal to integration of dx minus integration of cos x dx. This is equal to integration of x minus integration of cos x is equal to sin x plus c. Question number 16. Integration of cos root x by root x. While going through this question, we can see that d by dx of derivative of root x is equal to 1 by 2 root x. So we can integrate this by substitution, or put root x is equal to t, differentiate 1 by 2 root x dx is equal to dt, 1 by root x dx is equal to 2 dt. So this equal to integration of cos, replace root x by t divided by, and 1 by replace 1 by root x dx by dt, 2 dt, replace 1 by root x dx by 2 dt, cos t into 2 dt. This is equal to 2 into integration of cos t dt. This is equal to 2 into sin t plus c. Replace t by root x. This is equal to 2 into sin root x plus c. Question number 70. Integration of c square root x divided by root x dx. This also we can see in the previous question. Same way, we know that d by dx of root x is equal to 1 by root x. So we can do this by substitution. Put root x is equal to t, differentiate 1 by 2 root x dx is equal to dt. It is 1 by root x dx is equal to 2 dt. So this equal to integration of sec square, instead of root x we replace t, divided into, instead of 1 by root x dx replace 2 dt, 2 dt. This is equal to 2 into integration of sec square t dt. This is equal to, so the integration of sec square x dx is equal to tan x. So this is equal to 2 into tan t plus c, replace t by root x. This is equal to 2 into tan root x plus c. Question number 18. Integration of e raised to tan inverse x divided by 1 plus x square dx. While going through this question, we can see that derivative of tan inverse x is equal to 1 plus x square. So this we can integrate by substitution. Put tan inverse x equal to t, differentiate. You know d by dx of tan inverse x is equal to 1 by 1 plus x square dx is equal to dt. Therefore this equal to integration of e raised to, replace tan inverse x by t, e raised to t, replace 1 divided by 1 plus x square dx by dt. It's equal to e raised to t dt. We know that integration of e raised to x is equal to e raised to x. E raised to ta plus c. Replace t by tan inverses. Then this is equal to e raised to tan inverse x plus c. Integration continues on part 3.